Hello, this is Algebra 1, Semester 2, 5.2 and 5.3 exponential functions. I thought that we'd just consider our function equation for when it's both decay or growth, because you guys have been doing great with these, okay? So if we go back to our sequences, remember they're closely related. For the sequences, we could just go ahead and graph this, and you can see here that we're multiplying by 1/5. And if we count this as our first one, then at 1 we're at 25, at 2 we're at 5, at 3 we're at 1, at 4 we're at 1/5, and you notice the dots extending it on. So this means I can extend dots going down, okay? Going the other way, there were dots. I could find my x, or my y-intercept, and that would be 5 times 25, which would be 125, okay? Now I would like you to find y equals ab to the x. Hopefully you're already saying the b would be 1/5, because that's our decay rate. And now to find the a, remember yesterday we said that you can go back to this y-intercept. That'll be your a value, so it would be 125. Okay? Questions at all, make sure to bring to class. Here's the next one. This one you can see clearly right there. It's times 5, times 5. Might not have seen it so well there. Times 5, times 5. So this time, the first one we've got 1/5, then we go up to 1, then we go up to 5, then that's a little bit over. Then we go up to 25, so you can see the curves going the other way this time. So this is a decay, and the curve goes down that way, and this is a growth. And to find, again, my values, y equals ab to the x. My growth factor is 5. And when I plug in the x at 0, that's the y-intercept, it's at 1/5 here, and I need to back up and say what times 5 over 1 would give me 5 over 25, because it's going to reduce to 1/5. That's where it's at there. So 5, that would be 1, and that would be 25. So there's my value. 1 over 25 equals y. Okay? We do have a few real-world situations. I really like exponential equations for this. We have a rare trading card that we bought for $4. It increases its value at 40% per year. So we start at $4. That would be our a value. And because it increases, now let's think about this. If the value is $4, then you would say in 1 year it's at 100% of its value if it's still at $4. But we're saying it's going to increase 40%. So that 40% needs to be added to the 100%. If we switch them back to decimals, it would be, wipe out the percents, move the decimal over, it would be 1 plus 0.40 or 0.4. And so we have y equals 4 times 1.4 to the t. If you work that out, which you will in class, it's per year, so every year would figure it out. On the first year, it was worth, or on the 0 year, when you started, it was worth $4. On the first year, it goes up to like $5.60. Then it increases pretty rapidly because this is almost half of its value added back in every year. It's a pretty cool graph to look at, especially when you think about investments. Now here's more commonly what happens to people is they'll buy like a $12,000 car. They know it depreciates 15% per year, but they don't watch when the car depreciates more than the loan that they owe because they're paying interest on a loan. And they may not be paying it off quick enough. So again, we have y equals a 1 plus the r, but this time, think about it, 12,000. If it stays at 12,000, it would be 100%. But because it does not stay at 12,000, it says that it depreciates, it goes down by 15%. Instead of the 1 plus r for the depreciation rate, we go to 1 minus r. So now we would have the 12,000 starting amount. 1 minus 100% minus 15% would be 85%. Switch it back to a decimal, you'd have 0.85. That's what causes it to decay or depreciate, is because it's less than 1. Okay, last little thing to look for this section. We're given graphs. This is of two different stocks. Stock A starts at $16,000 or $16 per 100, I'm not sure which. In the first year it drops down to 15, and then it just continues to go down. Stock B starts at 4 and goes up to 5. So first thing we ask, are they growth or decay? Hopefully you're looking at it and saying, obviously, whoa, I'm sorry, I didn't realize that I was off camera. Let me adjust that. Wow. Okay, so this is stock A. It's decaying. Whoops. It's decaying because it's going down as you go to the right. Stock B is growing, or it's a growth value. Okay? Now, I said on stock B that it starts at 4. And we would actually do this for the graph, so it would be x, not t. And so we know that it goes from 4 up to 5. If you think of your sequence, you can write 5 over top of 4, get 1.25. That's your growth rate. Now that's the easiest way to do it when you're going to end up with decimals, by the way. Now for A, we know that it's a decay. We have y equals, I told you it starts at 16. And then the second year we see that it goes to 15. So if we think about our rate, again we write the fraction to find our growth rate, 15 over 16. And you can put that in decimal form or you can leave it 15/16. Okay, have a good time tonight. I'll see you in class.